right, so let's go ahead and continue our discussion from last week on the different ways that we measure things in chemistry as we continue this kind of introduction as we go along, adding new things. Some things are going to be familiar to you, but today's topic is on density. Now, we talked previously about mass and volume, and so we're just adding a little bit to that today in our lesson because remember, mass is going to be usually measured in kilograms. That is the SI unit. But volume is actually what we call a derived unit, if you remember that from last week again, because a derived unit means you have several base units put together. And in volume's case, it depends on how you're measuring. But so, for example, if you're measuring a cube, then you would have three sides that you're taking into account. So those would be your three linear measurements. Measuring something linearly is going to be a base unit, and so putting those together is what we call a derived unit. Density is also a derived unit because you're taking mass and volume. So we're going to talk a little bit about what density is, and then we're going to work out some density problems. So make sure you have your calculator, make sure you have some paper to write on. I did leave some room in your notes, so if you want to write in that space, if you print out your notes. If you don't print out your notes, which you don't have to, remember, you can just grab a piece of paper, have your calculator, which you can use, and we are going to learn how to use the density formula. But let's talk about what density is first of all, and then we'll go from there. So with density, what I'm looking at is how much mass do I have in relationship to volume. It is a ratio, and that's why you can write it mass over volume or mass divided by volume. And so why do things float? Why do certain things sink? One of the things we're going to learn is not only to be able to figure out mathematically about density, but we're also going to use this in our lab this week. And so we're going to talk through a few minor things so that you are better informed for your lab this week. So looking at my example on the screen, you have cork and you have wood, and then you have a metal, in this case aluminum. So why is cork really floating, wood is sort of floating, and aluminum is starting to sink? And that is because of their density in comparison to water. So water has a density right about 1. It's like 0.99 something. So we usually just say 1. So it has a density of 1. So anything that is less than that is going to float like cork or like wood. And then anything that's heavier, a larger number than 1, is going to sink into the water. So think about the size of those three spheres. They look identical. We're going to assume they are from this clip art. And so they are going to have an identical volume. When I measure it, when I take the circumference and I measure out the volume of a sphere, I can measure then the volume. So what is different? What makes these three different? What do you think, class? Absolutely. Some of you got it right. So the mass is going to be different because we're dealing with different material. Think about the cork. Cork has air pockets, right? Wood is just a lighter material than metal, but it's a little heavier mass-wise than the cork would be. So when we look at the density, we're not only taking, well, okay, let's measure it on the scale and see what the mass is, but then let's take the volume. And when we do a comparison of that, we can get density. And that's where we'll use the term, well, that was dense, or this is less dense or more dense. We will talk about this throughout the year. Density in this component of our conversation is just the start. And then we're going to add to it as we go along and as we talk about specific material, like solids and liquids and gases later on, and we'll look at some of the comparisons there as well. So density equals mass over volume. You may write that down on your paper. You can also use something called the density triangle, and all this does is give you kind of a picture, and let me show you how it works. You do not have to use it at all, but anytime you have three different parts to your formula or your equation, you can use something like this. So if I want to solve for density, I would cover it up like this, and then I would say mass divided by volume. Okay, that seems easy enough. Well, let's say I wanted to solve for mass. Well, to solve for mass, it's density times volume, and you might have guessed it. If you want to solve for volume, it's mass over density. So you can use the density triangle or just write D equals M over V and then manipulate it as needed. So let's remind ourselves of a conversation from last week, and that is when we are solving word problems, mathematical problems in chemistry, there are some must-haves. as what I'm calling them. And so you should have written this down last week, but some of the must-haves in order to get all of your points on a problem that you're solving. You're going to write out the givens and the unknown to make sure that you're on the right track with that. So you'll write G, write any givens, a U, and write, or you can say known and unknown, K and U, that's fine. I say given just because that's just how I learned and how I remember it. Then after you've written that, you're going to write out the equation or the formula. Again, equation and formula I use interchangeably as terms. So you're going to write that out. Then you have to show your work. Then you're going to make sure you include your units in that final answer and then give it a nice, neat circle so that my eye goes right to that answer and I can then work backwards as needed. So, are there any questions about the must-haves that we talked about last week? Because we're going to put them into practice again this week. And then you'll need to continue that through the rest of the course together. I know we're early on in the course. We have many, many weeks together. So I want to make sure that you have that answered. And please be neat. That's another important thing. That's probably one of the more important must-haves is please be neat. But I'll just say that and not type it out. Okay. Email me if you have any questions on that as well. So let's practice a couple of these. And so let's go through this first problem. And remember, with any word problem, you're reading it all the way through. Then you're picking out your unknown and your givens and you're writing those down. Then you're going to write down the formula and then you're going to solve it. So let's look at this one together. In an experiment to identify an unknown gas, it is found that 1.82 liters of the gas has a mass of 5.430 grams. What is the density of the gas in grams per liters? Now, we talked last week about converting, especially in the metric system, liters, milliliters, and things like that. Notice the first thing I noticed with this, I'm going to circle it, is I noticed what my unit is asking for at the end, and I noticed that I already have the correct unit. So there's no converting to milligrams or milliliters or anything like that. I can leave it as is. So here's what I want you to do. I want you to go ahead and try this problem. Okay, I'm going to leave it here on the screen. While you're doing that, I'm going to write on my paper, turn on my document camera for you to see the final answer, and then we can match up what you've done. So don't forget to write out the givens, write out your unknown of what you're looking for, and then go ahead and solve it. And like we did last week, if you will type the word done in chat when you're done, then that gives me an idea of how quickly or how slowly I need to go. So go ahead and let's solve this problem. You may also abbreviate. You do not need to write out mass and volume when you write out your formula, your equation, or density for that matter. It can simply be D equals M over V. All right, so enough of you have finished. Remember, I do try to give plenty of time, but sometimes you're still working, and that is perfectly fine. But I'm going to go ahead and share with you my work so that you can see the answer, the must-haves all set up, and then I'm going to circle my answer at the end so your eye goes right there to the final answer. Any questions on this one? We're going to do several throughout our time together today, and next week you'll have some practice in homework as well. All right, if there's no questions, we are going to move on to one last topic on density, and that is to talk about what is coming up with lab this week. So you are going to be measuring in lab. And when we get to homework at the end of our class time together, I'll go over a couple more specifics. But I just want to do a quick lab chat, talk to you about finding regularly shaped objects and irregularly shaped objects. So your lab is going to walk you through this as well. I'm just going to give you a few pointers. So finding the mass is easy. Use your scale. Okay, so find the mass on the scale, super easy. The volume is a little bit more of a challenge, depending on if you're dealing with an irregular shaped object or a regularly shaped object. So I'm going to stop sharing for just a second so that I'm a little bit bigger. My picture's a little bit bigger. So when you are finding regularly shaped objects, in your lab kit, you have a marble. You also have a cube. I do not have a cube because I mailed them all out. So if you find your little density cube, it's about that big. Well, what we're going to do with that density cube is you're going to measure the volume using a ruler, side times side times side. So you're going to measure it that way, find the volume, use your scale to find the mass, and then you do the math to find the density. You can also do that with your marble, just a little bit trickier. What you need to do is take a string and go around your marble and then put it on the ruler, and that will help you to find the circumference. And then you're going to have to use the circumference volume formula to find out the volume of this. So that's how you find regularly shaped objects. But we can also use something called the water displacement method using our graduated cylinders. Now, we talked last week about how to use it, meaning it has to sit on a table. I am holding mine in my hand, so it's high enough for the camera to see. So please don't do it this way, okay? Actually put it on the table, get down to the level that you need to for reading the meniscus, okay? And so how do I use water displacement? Now, you can use water displacement, and you will for your lab, to find the volume of your regularly shaped object. And you're going to compare that to the volume you measured the other way. But you're going to be asked to look around your house and find an irregularly shaped object, maybe like this screw that I found in a drawer, okay? I can't measure this very well with a ruler. That would be hard to do, to get all the, lines eliminated and all of that. So I'm going to use the water displacement method. Now remember, you're not holding it, you're on a table, okay? So when I look at the meniscus, I see that it is right at 30. I didn't mean to do that, but it's right at 30. Okay, so that is my initial volume. I'm going to gently slide this in, and then I'm going to read the new volume, and it is at 31. So the volume of this screw displaced 1 milliliter. So that is my volume. Then I should have done it before I've got it wet. I'm going to put it on my scale for the mass, the volume I found using the water displacement method, and then I can do D equals M over V to find the density of an irregularly shaped object. Now, again, I'm going to do that with my marble and with my density cube. So you'll see that in our lab document this week. But I did want to demonstrate to you how to use the water displacement method so that you would know how to do that for your lab this week. Now, it is time to take our 5-minute break, so we're going to do that. When we come back, we are going to we're going to do one more density equation word problem, and then we are going to move on to something called precision and accuracy. So be back in 5 minutes, please.